framework. The challenge can be that talking to people about it can be quite difficult if they've either never used it or used it just a bit, read a bit about it. So what I'm trying to go for here is, rather than sort of talking through the ABCs of syntax and so on, is actually more getting you across what kind of things it can do, and getting you to think about how you might be able to use it in your projects, and sort of what it might add to your project, that kind of thing. And it involves a big change in mindset about thinking more about event flows and so on, rather than imperative programming. And that's more what I'm trying to talk about in the talk than the individual syntax bits. So if any of it looks like garbage, it's probably just my code. So if you don't understand it too much, don't worry about it. So just to get me across, like where people are up to with RX. Has anyone here used it heavily and know it well?
Oh. We put it into a WPF Calibre micro app for some reason. I can't remember why, so we used to know it heavily.
Okay. So anybody else used it in production servers or production apps, but not heavily, right? So most people haven't used it at all? Cool, okay. So in that case, definitely, if there's bits and pieces that don't make sense, especially when we get to the examples, don't worry too much about the actual code. Think more about what kind of problems it can solve for you. So RX is basically, for anyone who hasn't done any looking into it at all, it's a lot like what Link brought with enumerables, but for looking at data that's actually moving. And enumerables are generally data that's already happened. It's caught up in one little bundle here, and you're looking back in the past. RX is letting you look at data that's moving, it's data that hasn't happened, future events, that kind of thing, and setting up the ability to react to those events when they happen. And it's about sort of modeling the event flows through your application, and the idea being that you sort of design more around domain events that make sense to your application, like new orders and new customers and that kind of thing. Yeah, and it's reacting to asynchronous events, where asynchronous, you're talking about an event that's pushed at you at some time when you've got no idea that it's coming, and you just have to deal with it when it arrives. Whereas with enumerable, you're always, when you're ready, you go and ask for something new. When you're not ready, you don't ask a question. With RX, you have to be ready whenever it happens. So just to give you an idea on what my experience is, I spent a couple of years working on a project that used RX in basically everything, and it really transformed the design of the app. And a lot of what we did would have just been a lot harder to do without RX. Behind the application was Nirvana Messaging, which, if most people haven't heard of it, it's just another message bus. It's like TIBCO. So we used it for publish.
Does that mean it's horrible?
Sorry?
It's horrible then?
It's less horrible than TIBCO.
Okay.
So it's actually quite good, but it's certainly not easy to get started with. But we used it for publish, subscribe, and we used it for request response messages over message bus as well. And sort of in the limited reading I've done around this, there's some stuff around there in the web about using message style interaction even for web service style calls, and that's what we did, and that worked quite well as well. And so because of that asynchronous message bus, it ties very well with RX. We used RX on the UI and on the server side, so it was basically to deal with everything from a button click through to pushing messages to the server and then pushing responses back and getting information in from external systems. And yeah, as I said, almost everything that we did was happening through RX, even if it wasn't dealing with RX code in every method. It was often, almost always happening inside an observable, inside RX code. So I've sort of talked about this a bit before, but the point of this talk is to give you ideas about what it can do, and hopefully if you can sort of think about how that applies to you, you might go, right, now it actually might be worth my time going and learning RX, because it definitely takes some time. And if you get someone up there just going, right, this is how you plug this and this together, it doesn't really mean much, and you don't come away with a reason for why should I bother spending my time learning this thing. So yes, to get you thinking about your system and what kind of events happen and what you could do if you could tie some of those events together and react to certain scenarios and sort of how that might give you better capabilities to pick up anomalies or do reporting or do things more simply. And as I said, not to teach RX 101. And there is some good stuff out there to teach RX 101, which would be much better than I'd be doing it anyway. Alright, so there's a bit of motion sickness in there for you. So what's the point of RX? For anyone who's just got no idea, never looked at it at all, the problem RX is trying to solve is that actually, despite how we treat it, a lot of data that we use these days is not really static. And we kind of treat it, we go and get it, and then we assume it's not going to change, and we deal with it. And if it does change, or we kind of hope it doesn't matter too much. So RX is dealing with data that's sort of, it's temporary, it's going to happen and then disappear, like a new order request appears out of nowhere, you have to deal with it, and then it's dealt with and it's gone away. Or data that sort of lives for a long time, like user preferences or something, but it doesn't stay the same over that time, it's moving around. And if you sort of think about most apps you write, they're all, I think every app I've ever worked on, except for like a file importer, has basically been event-driven. It's looking for someone to push it into doing something, and that might be a UI button click or a request to a web server, message on a message bus, or people tweeting or adding stuff to Facebook, whatever. It's all something else happens, and then you do something, and that's what RX is really built around. Is sort of modeling those flows of these external events happening and letting you build your intelligence on top of that. I haven't worked in big data myself, but it would be a really neat fit with RX. It's all sort of transformational, on-the-fly kind of data, and I imagine if you were a large-scale US surveillance agency, you could do some really cool stuff with RX if you were tapping into some fiber optic cables.
That would never happen.
No, actually it would be interesting to see if it coped with the scale. So as I sort of hinted at before, RX brings a bit of a change of focus in what you're thinking about when you're designing your code. And you're building it on sort of streams, they're called streams of changing data, events that are happening. So it could be like user preferences, instead of their one preference, it's a stream of their preference, and every time they change that preference, you'll get an update. Or events like a stream of new requests and that kind of thing. So you build up these building blocks, and then you can compose them together and build some quite rich flows out of that. If you use it well, which took us some time to get in my previous project, you end up with a design that looks like it's designed around the flows of business events, which works really well because when you look at what the RX is doing, it's reacting to new orders, reacting to changing customer data and so on, and you can sort of see what the business requirement is trying to solve is, and it's quite declarative. It uses link, so basically the same declarativeness that you get out of link with enumerables you get with RX. So if you like that, you'll like RX, and if you don't like that, you won't like RX. So I talked about this a minute ago, but thinking about static data in our systems, often we sort of have this data that we treat as static, and if it changes, the user has to log out and log back in again, or we have to shut down, it'll get picked up the next time the app recycles or something like that. And sometimes the data isn't really all that static. Things like user preferences and permissions and so on, they will change, and sometimes you just sort of cope with the fact that you might be using out-of-date data, but RX can let you deal with changes in those data without any sort of extra effort, which can let you say if you had a user preference for a currency that they wanted to view all the deals or all the things, the products they can buy on the screen, and they go and change their currency and the user preferences. You could have all your already open tickets that have got all their products they're looking at, flip over to the new currency, show the new price, with exactly the same code as you would use to set that up the first time you open that form. So it takes data that you were treating as static and sort of makes it magically able to cope with changes. And what we found in our project was that suddenly all these user preferences, especially user preferences, were update it on the fly, and also with permissions. We had an external source of permissions. If someone was doing something where they were permitted to and then their permission got cut, that would just stop. Whereas in a lot of systems, if they're sort of about to buy something that they're not allowed to buy anymore, you kind of missed the boat, or you might have missed the boat, and you have quite a tricky problem to deal with that. So yeah, this is sort of one of the things that RX can make you do is think about, is your static data really static? Would there be value for us in dealing with changes to this on the fly? And if the cost of dealing with those changes is low, what can we do with that? So a lot of people, or some people will call RX linked to events, and that's actually a really good way to think of it, because that's exactly what it is. It's writing link over the top of data that is events, and that can be .NET events or any other source of events like web service calls and so on. Anything that is pushed to you, you can transform that into an observable and then use RX, use link over the top of that to, take one, skip one, aggregate them, whatever you want to do. So with IEnumerable of T, you've got sequences of data, and link brings all the queryability over that. And with iObservable, which is the RX version of that, you've got the sequences of events, and you've got link on top. But the one thing you do get with RX is about 1,000 new extension methods that come with it. 1,000 is an exaggeration, but you get a lot of new extension methods that do all kinds of stuff that makes sense much more in a sort of a timing scenario, that kind of thing, which don't make sense for enumerables. Things like intervals and time-based operations. So I've got some examples here. One thing to say, I'm using LinkPad for the examples, and I don't know if people here have used LinkPad or not, but it's a really awesome tool. It's great for learning RX, it's great for learning Link, it's great for learning C#. Anytime I think, hang on, what happens, does C# deal with this or not, I just go and write in LinkPad and I run it, and you've got your answer in 1 minute. It's a really cool tool, and it is free. You need to pay for IntelliSense, but apart from that, it's free.
And Australian made as well.
Yeah, that's true.
Really, wow.
Yeah, it's the Albahari guys who are in Perth, I think, is it? Brisbane now.
Yeah.
No, he's from Perth.
Is he?
Yeah.
They wrote C# nutshell
Yeah.
books in the proper guides and all that.
Yeah, they're smart cookies.
They are, yeah.
All right, so what I've got here is this is sort of mimicking a Twitter feed with users voting on Prime Minister candidates while they're watching a perhaps never actually going to happen debate between Tony Abbott and, for an election that may never actually happen. So we've got, basically it's simulating some tweets coming in, and people are voting for Kevin Rudd or Abbott by just putting the hashtag KRudd or Abbott in their tweet. In order to generate the worm, we want to sort of take a chunk of tweets over time, fairly regularly, so we can get a fairly smooth worm, but we don't want to take, say, 1 second's worth of tweets, because it might be quite volatile how many people are able to tweet. And so if we say take maybe 5 seconds worth of tweets, but take that 5-second chunk every 1 second, so we still have the graph updating 1 second every second. And just count the number of tweets for K-Rudd, count the number of tweets for Abbott, and work out what percentage of that window belongs to Rudd and what percentage belongs to Abbott. So just to have a quick look at the output, you give it a few seconds to get some tweets in, and then we start seeing some numbers coming out there. And these are just randomly generated numbers of tweets, so it happens that we generate pretty close to 50-50 most of the time. But you can sort of see that those percentages there you could then use to plot an up and down graph to see whether the audience likes Rudd or Abbott. And if it wasn't a randomly generated Twitter stream, then you'd have probably a bit more strong signal, and you'd have moments when Abbott's up at 80 and moments where he's down at 20 or what have you. So in terms of how we actually go about doing that, what we've got here is, this is the tweet stream that's simulated, so it doesn't really matter the implementation of that, it's just a bunch of random text pushed out. But what we do is we take those tweets, and we use this buffer extension method, and we're saying, give me a buffer of 5 seconds worth of tweets, and give me a new buffer every 1 second. Sorry. So I want my buffers to be 5 seconds large, but then I want them offset by 1. So the buffers will overlap. And that's basically the real guts of what we're doing here, is just getting those buffers. And once we've got that, you can do whatever you want with that data. So all we're doing here is just saying, right, so given a time slice, Kevin Rudd's votes are the number of tweets that have K. Rudd in it. Abbott's ones are the number of tweets that have Abbott in it. And then some quick and nasty anonymous type to work out how many votes did he get divided by the total number of votes, how many votes did Abbott get, and that's all it is. But the real crux of generating that data comes out of buffer. And one thing you find, as well as having a lot of extension methods, is they'll have a lot of overloads of those methods. So this is one particular overload that gives you overlapping windows, but there are all different ways you can create buffers and tell it when to start a new one and when to close one and so on. And it's closely related to another one called window. The difference is window will give you what's inside that buffer while it's happening, whereas buffer will give you the buffer once it's all full and it's finished. So window tends to be a bit more complicated. Every time I write something to use window, I end up using buffer. Okay, so the second example we've got here, and this is sort of a style we used a lot in our project. It was a big integration project between various servers, and we had one server. It was a finance system, and it published FX rates out to the UI that people could then do trades on. And it had two systems behind it, one that gave user permissions to trade the FX rates and what currencies they were allowed to trade on, and another system that would actually be able to deal with the executions and go and work out and say, right, you've booked this trade, this is what you've got. So if either the permission system or the execution system went down, we couldn't actually give prices to the users, because they'd actually be able to get themselves into a state of booking something where we weren't sure if they were really allowed to, or we weren't sure we could actually go and execute it. So what we wanted to do was to monitor the state of these two services, and then if either one of them went down, we cut our prices off. And then as soon as either one of them came, as soon as they were both back up, the prices would just restart and sort of insulate the UI from this. And so don't stop the stream and then have to restart it, just have the stream go quiet and then have the stream come to life again. So what this does is, this example is just producing the heartbeat version of that. So we watch the two servers for heartbeats, and I've got a little helper here which will read numbers I type off the console. And if I type a 1, it's a heartbeat for server number 1. If I type a 2, it's a heartbeat for server number 2. So if we start it up, I've got it set up so if you don't heartbeat within 10 seconds, we'll treat you like you're down. So if I start it up and I don't type anything, eventually it will complain that it's missed heartbeats for both of them, and we get the state for service 1 and the state for service 2 both down. If I type a 1, and we instantly get service 1 heartbeat, and we get a new value straight through saying service 1's up. And with service 1 heartbeats again, I don't want to be told again that that the state is up for 1 and down for 2, because nothing's changed. And if there are things listening to that, trying to react to that, if you keep telling them the same information, they're going to keep reacting to it. So what we've got is something I'll show you in a second. It'll only publish a new update when it's different from the previous one. So if I say both of them are up, now we've got a new update where both of them are up there. And that's in a nutshell the basic approach we use to monitor these two servers. And only when both of them were up were the streams open, and if either of them were down, we stopped publishing until they both came back up again. So the actual the crux of this is so this is the heartbeat tolerance here that I was telling you. So we're going to give it 10 seconds. And what we do is we say, right, so this is where we're using composability of ARIX. We've got one stream that will produce a down state. So this is going to say the service is down. And what we're going to do is delay that stream by 10 seconds. So after 10 seconds, it'll say you're down. And we've got another stream here, which is looking at those heartbeats that I'm pulling off the console. And then as soon as one comes through, it'll say that service is is up. So basically we're having a race between the heartbeat and the downstream. So if the heartbeat comes through in less than 10 seconds, it wins. If the downstream comes through before that, it wins, and we'll say it's down. And so what we're doing here, there's this little method here, and I think I'm not a functional programming expert by any means, but I'm pretty sure this is a functional, one of the many functional pieces in RX. And what this is saying is a shorthand for ambiguous, and it's saying take whichever one of these two streams gives me a result first. So if the heartbeat comes through first, I want to listen to the heartbeat. If the heartbeat doesn't say anything and we get something from the down thing in 10 seconds, I want to listen to that. So take the first one of them, so whichever one comes through, a heartbeat or a down, and then just keep doing that till the end of time. And then this little guy here, the distinct until change, is what's stopping me from publishing the same state over and over and over again. It won't publish again until that state changes. So there's a number of ways you can solve this. This is just one of them. It's sort of conceptually, when I was thinking of how would you implement this, you're just trying to work out which one happens first. Your heartbeat tolerance expires, or you get a heartbeat, and then as soon as you get a heartbeat, you want to wait for another heartbeat tolerance and just wrap that up and keep doing it. Any questions at all on either?
If you had a third stream, it would just be ambiguous.
Yeah, so if you have a third stream, well, it's actually the heartbeats. This method is given the service name, so it's generating a stream of updates for only that one service. So if you have an extra service, you call this method one more time. So we're actually calling this method twice here. So
No, I'm talking about you've got maybe a second heartbeat going on or something weird.
Like as in we get two heartbeats in the same period of time, or?
No, it's probably a bad example, but you've got a signal coming for down, you've got a signal for a heartbeat, where you had an interrupt, for example, that you were listening for.
Okay, in that case you'd have a bit more information on the actual heartbeat object coming through. So all I've got here is if I type a 1, it's treated as a heartbeat. But if you could have an actual object saying this is the heartbeat and this is its type of heartbeat, and you could be listening only for heartbeats that aren't interrupts or whatever you care about, that kind of thing.
Do you mean like a third state?
Yeah.
Like a third state, so there's down this up.
Or a shutdown signal or something like that.
Right, so you're saying you've received a shutdown signal from this service, or you're...
It's just I'm just trying to make an example, so the third thing we're listening to in that section of code.
Right.
So it's a heartbeat, it's a down, and it's a something else.
You got 3 states.
Yeah.
Yeah,
So
so...
we just chain them?
Yeah, you could. I mean, you can. Amb just returns another observable, so you could always. Yeah, you can just amb on the end of that. But often, off the top of my head, I don't know how to do that. But I think it's partly more because I'm not quite sure exactly what you're getting at. But yeah, it's.
And so, just curious again, why don't we get the down signal every 10 seconds?
So we don't. The reason why we don't get the down signal every 10 seconds is because we're waiting for one value to come out of either the heartbeat or the downstream.
Yeah.
So as soon as we get that
so
one,
we pick up a heartbeat.
Yep. And then we've got, and this take one then goes, right, I've got my one value, drop what I've got on the floor. So if I were to delete that line, there, the repeat, we'd only ever get
so
one
that drops
heartbeat.
the down.
It drops both of them. It stops listening to the downstream and it stops listening to the heartbeat stream.
Okay.
Because we got one value came out the other side, whichever one, and then we'll unsubscribe.
Okay, so it's take one and stop listening.
Yeah, that's right. So if I
just take the first one.
Yep.
Okay.
And so if I delete the repeat, then we'll only get the first heartbeat of the first down, and then it will never push again. So this is the way I came up with in my head to do that. So you want sort of a never-ending repeat of a race between a heartbeat and a down thing.
Okay.
And so the good part about this design is that you only once that repeat comes through, you start listening for the down again from scratch. Yep. So if you get a heartbeat at 9.5 seconds, you don't get a down thing 0.5 of a second later. You get a down another 10 seconds after that. Another way of doing this is instead of using amp, is there's a timeout method. So you can you can put a timeout.
Do take
there.
one with a timeout.
Yeah, exactly. And the timeout you can tell the timeout, if it does timeout, continue with this observable. So you could say timeout and continue with something that says I'm down, and what's coming through says I'm up, and that's another perfectly valid way of doing it.
Okay.
Alright, so a third one I've got here, this is sort of trying to generate some business information about orders that come through to your web service or whatever, and all I'm using that console trick again, and I'm just typing numbers into the console that represent the total amounts on an order, so $100, $5, whatever, and we're sort of trying to generate some live stats about what orders are coming through, and again using that same kind of approach as we did with the tweets, saying give me 5 seconds worth of orders every 1 second, so I'll get a new bunch of information every second calculated on 5 seconds worth of orders, and you could do that on 5 seconds, 5 minutes, 5 hours, whatever you want. So what we're trying to generate is how many orders did we get, what was the largest order, what was the average, what was the total of all the order amounts. And one thing to note with RX, and it's the same with, it's just link, it's not RX specific, is when you're doing this kind of aggregation, you don't have to flatten your information like you would with SQL Server, with SQL. There's no reason why you can't still hold on to the entire set of information that you based this from. And then anybody listening to this stream and doing some more work could go through and say, oh, okay, so the biggest amount was this. I want to go and work out which of these orders were within 5% of the largest order, that kind of thing. So it's one of the beauties of Link is that you can aggregate without losing the individual rows or records that created that information. So if we run this and I just start typing some random numbers, then after 5 seconds we start getting some information there. And if I stop, what you'll see is eventually the window slides off. You get 4, 3, 2, 1 here, because I've stopped adding orders, and slowly that window is rolling forward and it's getting less and less orders because I stopped adding them. So the point of this isn't because this is some kind of genius code, but what you can do here with this kind of approach is you could set up triggers to look for particularly high value orders and email your relationship managers and say, hey, this guy just put through a huge order. You could look for sudden spikes in a number of orders and log that kind of information, so you can say, hey, around this time we suddenly got a lot of traffic. It might be useful to know why. Or the inverse, suddenly we lost a lot of traffic, what's going on, we're losing money. You could even do fraud detection. This customer's put through 1,000 orders in 5 seconds. I'm probably convinced that's not quite accurate considering it's from a website. That kind of thing. This way it's there's a lot to learn with RX in terms of the syntax, but the point is much more thinking about your domain and what you could do, thinking about your events and tying them together like this and building queries and reacting to certain scenarios on there. So that's pretty much all the examples I've got for sort of showing the kind of thing you can do. I've got a few more slides to talk through, but did anyone have any questions about any of that at all? I haven't posted the code online yet, but I will do.
How would you test that?
It's funny, it's actually not as hard to test as you'd consider. The timing can be a little tricky to test because obviously you don't want your test sitting there waiting 5 seconds and then making sure it times out and so on. But the RX guys have created, it all runs on schedulers, and there are virtual schedulers that provide sort of timing, and you can grab a hold of a virtual scheduler and say, hey, just pretend 5 seconds just passed. So you can write there, and it's quite a neat way to do it. You can write unit tests that say, you've given me an update now, and I don't want to, I'm trying to implement code that doesn't give me another update for 1 second so I don't flood whatever I'm sending my things onto. So here's an update. I'm going to create something that should cause another update and make sure I don't get called again. And then I'm going to push time forward by 1 second, and now I should get the update. And it's actually worked out to be relatively simple. But you do end up, the one trick, and this is something a guy I'll talk about a bit later, he's got a good design for sort of passing around this collection of schedulers because there's one for the thread pool and one for the task pool and one for the dispatcher and so on. Passing around basically a big collection of test schedulers without your production code knowing whether it's got real schedulers or test schedulers, that kind of thing.
Schedulers, you mean task parallel library schedulers?
They're not the exact same types, but I assume it's pretty similar in concept. I'm not a scheduling expert. I think if you start looking at the scheduling interfaces, you quickly end up in some pretty serious code.
Mm-hmm.
In terms of not talking about the scheduling side, with RX, there's always some source of the events. It's either already an observable, or it's a .NET event, or it's a method call into a class, that kind of thing. So there's always a way you can poke it and then check to see what comes out the other side. So for this, for example, this is using a console observable to have its source of deals, but in a test you could have something else. It's just an observable of decimals, and you say, right, push 5 of them through, subscribe to what comes out here, the order stats, and go do some checking. And so it does actually come out to be quite, the tests come out to be quite data driven, and you don't spend much time mocking. And if you end up mocking observables, it's probably not the right approach. It's probably a bad sign, a sign that either the test has got a problem or your code design's got a problem.
Did you have any issues with presentation, like continually getting data every second?
Yeah, we did have, the only issue we did have was, so we had a Silverlight front end for this, to try not to laugh too much. So it was getting streams of prices from our back end, and the back end was capable of sending far more prices than the front end was capable of showing. And especially when what you're doing is, it's finally at the last point, you're trying to push a UI update onto the dispatcher, which is already busy drawing the rest of the screen and so on. So that did present some challenges, because RX is designed to sort of deliver every notification and deliver it in order, so you won't push the next one through until you finish handling the first one. Otherwise you get, if it doesn't sort of adhere to that contract, you out of the box get a whole bunch of problems with, oh hang on, I processed this update before that one, but they were meant to be in the other order, that kind of thing. So there was one challenge we had with that was, for getting flooded with prices, in the finance world for FX rates, as soon as you've got a new price, the old one's useless. You just want the latest one on the screen. So if you've got 100 of them waiting to be put on the screen, you don't want to go through and put every one of them on, and that's how you'll back up and you'll build a bigger and bigger queue, and you'll never get out of it. So there was a bit of it's not quite a hack, but it's a bit of a what's the word, improvisation with some code. One of the guys on our team basically decompiled a little part of RX and modified it so that instead of keeping a queue of updates that it's going to push to you when you're ready, it just has one update, and every time it gets a new one, it loses the old one and keeps only the most recent one. And that basically it's like a blow-off valve for pressure that gets built up. So there's all these updates waiting to happen, and at that point the dispatch is really busy. We don't care about drawing ones that we know are old, and they all just get dropped on the floor, and only the latest one comes through. But apart from that, that's the only real time we ever had problems with it. So as long as your UI is fast enough, then you don't really have much of a problem.
Is debugging a challenge for this?
It can be, yeah. That's one sort of, I guess it's a criticism I'd have, is it can be quite challenging to debug it. What you end up doing is when it reacts to an event, you'll typically have it go off and call a method, and the part where it can become the hardest to debug is when someone's decided that because you can write anonymous delegates, you should, no matter how big the delegate is, and you end up with a chunk of RX that's that big. And it's reacting to 7 different events, and it's doing all this code in here, and it's all in a big query statement, and you're like, how am I supposed to debug that? I find the RX will be easier to read if you refactor little bits like that handle a message request or handle an order request or something into a small little method, even if it's only 2 lines long. And then you can give the method a name, and then someone reading it can see that. But it also makes it much more easy to debug, because you can just put a breakpoint in the part where you think there's a problem, and all the calls will come into there, even though it's being executed in the middle of a giant monad, effectively, that's running in RX. it still throws plenty of problems. There's a tool out there called Debuggable, which I've used a little bit, which basically you take your observable and you call .asDebuggle on the end of it, and you use that. And I think every time it steps through any select manis, wheres, anything, it just prints to the trace or something. So it can be useful if your observable is acting in a funny way to sort of go back and sort of read its black box basically and work out what it
Is
was
it any
doing.
different from normal mint?
In terms of debuggability.
Is it more harder? Or
It's the same really. It's as you build it, because you're reacting to sort of future events. It becomes a bit more difficult to think about and reason about. Whereas when you're sort of basing it off, you can see, okay, I'm about to run some link on an array that's got 7 elements in it, and I expect it should come out with 3 of them. With RX, you're setting up this observable. There's no data yet. It hasn't happened yet. And then something happens in the future. You can't sort of look at the source data at that state in time because it's not there yet. So it can be equally hard, or sometimes it can be a bit harder, but also more so just because it's harder to think about. But I think the flip side is if you sort of try to write that code that ties together multiple events without using something like RX, you end up with a whole bunch of classes with states and flags saying, okay, yes, I'm in the middle of processing an order for this client, and he's in the middle of changing his user preferences, and all this is that, and 7 if statements deep and that kind of thing. And I think that's also hard to debug. So I definitely wouldn't say it's always easy, but I think you solve hard problems with it.
Yes, there are 2 quick questions. One was like, I guess it's a little bit related to what you just said now. Like, what would be the signs that you know, in code that the signs that RX might be appropriate for this sort of problem? But you mentioned one of them. Maybe if you've got a bunch of is variables keeping track of all this different stuff, maybe it's better if it's done, you know, with RX.
Well, definitely if those variables are representing, has this certain thing happened? Did this event just happen? You know, you see, with UI code, you see a lot of, I'll validate this field as long as I'm not changing that field right now, that kind of thing. And those kind of nested events is basically what you're trying to model there. And RX is a tighter way to deal with that, because you can say, you can tie those 2 together in one piece of RX code, and you can see the relationship between them. And you can say, I want to capture states when they're updating this variable and then they're updating this variable, or those kind of things. And in those scenarios, I want to deal with it by doing this. And you can put where clauses on it, so you say only in the case when they're turning this on or they're turning it off. It's quite hard to explain in an abstract way because it really depends on your sort of actual scenario. But when basically RX is about sort of event processing. And if you're doing a lot of event processing, which in reality a lot of apps do, especially on the UI, then it can be quite neat. The only challenge is it does take some time to learn, and so it can feel like it's not a good solution until the point when you start getting it. And it's partly down to learning RX and partly down to learning thinking in a sort of stateless, functional event processing kind of way.
An application would have to change significantly.
Yeah, and it's one thing we found in my project is you can kind of tell when you're starting to get it because you actually find that the observable, the observable interface starts flowing through all your interfaces, and you stop feeling like you need to sort of subscribe to an observable, get something, and get out of it quick, and then go back to imperative code and do a bunch of stuff, and then fire some event back on another observable. If you find it's like IEnumerable. If you have your design set up so that you are moving enumerables through your system, and someone's concatenating something, someone's filtering something out, they're joining, they're doing that kind of thing, and they're just transforming the data and passing it on, that's when you sort of hit that sort of happy path, the sort of pit of success and so on, and you're working with the framework rather than against it.
Yes, and just quickly, one other thing, like, have you used RX for JavaScript much?
I haven't at all, no. It does exist. I don't know anything about how good it is or not. As far as I understand, it was written by the same guys as wrote it for the framework, so I assume it should be up to the same standard. I haven't heard much about it, to be honest. There's also, I found out today, RX for Java. Someone's ported it, and there's RX seems to be exploding because RX is open source now, so I think people are rapidly moving it place. So this sort of ties in a bit to the question you were just asking is some usage patterns to sort of hopefully if you're going to go and try RX to keep yourself on the straight and narrow. The thing you should be passing around as much as you can is observable. It's the first class object. I think it doesn't come naturally to people because in .NET an event is not something you can pass around. You can't say to someone, here's my event, but I'm only going to tell you when the first 3 happen or anything like that. You can't just pick that up in an object and throw it 5 classes deep down there. Whereas you can with observables, you can create an observable that represents the first 3 events of this type and then give that as a result of some function to somebody else who might only care about subscribing to the first one, or they might be subscribing to that and 10 other things, and you don't even know what they're using it for, but it becomes this sort of first-class object that is shared around and built on, and that's how you get that sort of composability of it. So yeah, pass the observable around. The more you're passing it, the more likely you are to be sort of following the sort of clear path, I guess. The more you find yourself trying to subscribe, get a value, and then deal with just one value, the more likely you're going to be swimming upstream. One thing I've seen around is people instead of either passing into methods or out of methods observables, they're sort of saying, hey, I've got an observable inside me, I'm not going to give it to you, but why don't you tell me what you want to do with it, and I'll hook you together. And so I've got a sort of a little example I knocked up with that. So if we've got some subscribe to number string here, so what it's got inside of it is an observable, but it's not giving it out, and it's not taking it in. It's hiding this observable inside the method, and it's saying, right, so you give me a delegate that will deal with numbers, so this will just give you 0 to 10 in numbers, 0 to 9. You tell me what you want to do with it, I'll hook you up with subscribe, and if you want to unsubscribe, you've got a disposable you can dispose, but that's it. And so if you want to sort of show all the numbers in that list, then sort of you can do that. You get all the numbers, and if you look at show all numbers, you go, okay, so subscribe to the number stream, and every number I get, I'll call dump on it, which is just a link pad method to chuck it in the console. And that kind of looks okay. That doesn't really seem too bad. But what if you only want to show the first one? What if you don't care about the rest of them? So you go, right, so show the first number only. All right, so I'll keep a little boolean here to tell whether I've got the first, whether this is the first number or not. And if it is the first, then I'll chuck it on the console. Otherwise, and then I'll set it false, and then I'll ignore the rest. But what if this isn't 0 to 10? What if this is 0 to infinity? How do I get out of here? I've got my one thing. I don't care anymore. So, all right, I'll grab this subscription, this disposable that returns to me, and I'll dispose it in here, inside the handler. But it hasn't actually been set yet because this handler doesn't return in this case until all of the numbers have been pushed through. So you're sort of stuck trying to model the state of this thing and just and sort of keeping all these flags and so on. And it's sort of, okay, what if you wanted to show the average of them? You don't want to deal with one number, you want to deal with all of them as one piece of information. So how would you do that? So, okay, we can subscribe to it, and every time we get a number, we'll chuck it in a list, and then after we get all the numbers, then we can go and do an average on the numbers. We can go and do an average on the numbers and dump that out. But have we actually finished? Have we got all the numbers by the time we finish this call here? And that really depends on the observable you're talking to. If that's hooked up to an event, that will never finish. You can't tell when an event has finished publishing values. For observable.range, it will work because observable.range returns 0 to 10 straight away and then dumps, and it's all synchronous. So it's really quite a nasty little interface, all because this guy here doesn't want to give us its observable. But if you change all that and you go, and so to show all the numbers, if you go, right, what if I have this, get all the numbers, just give me an observable of integers. Then to show all the numbers, all you have to do is subscribe to it and chuck it on the console. That looks pretty much the same, doesn't feel better or worse really. If you want the first one, you just go, oh, just give me the first one and dump it. And as soon as that, this is what we were talking about before, as soon as we've got one, then that observable we got, it's unsubscribed. It's disposed of it. So if that has to go and do some tidy up work, it's happened automatically. And another way of doing that to get just the first one is first async. They'll do the same thing. If you want to get the average of all of them, then you're back at just doing .average. So you're keeping that composability. And if you want to do something crazy like skip the first two, then take the next 5, then get the average, can you imagine writing that code with an approach like that, like this here? You'd be creating lists of information and setting flags and knowing when to start and stop. So the real key is that if you're passing around the observables as the first class objects, that's when you're getting that easy reusability, easy composability, and so on. So don't sort of hold on to your observables and help people use them. Give them out. They should be on your public interface. Any questions on that?
So if you were doing the 1 to infinity,
yep,
and you did the average, that's
Yeah,
effective. Is that a blocking call or is that async?
Let's have a look. I never remember because I changed some of them between RX1 and RX2. So you can see the return value there is observable of double, which means it's a non-blocking call. So you'd have to actually subscribe to the average, which is what dump does for you.
Okay.
So that's effectively the same as going subscribe, and then I'm getting an average. So in that case, you could say it's not a blocking call. You're not going to freeze your program, but it's never going to execute this because it's never going to complete.
Because you'll never get the numbers to go to the average.
Yep. And that's one concept that comes with RX a lot. And you like a stream of subscribe requests or booking requests on your server. You don't want it to end. You don't want to stop listening for people trying to buy products off you, that kind of thing.
So that's why when you do the take 5 repeat type routine.
Yeah, exactly. So when you're passing the observable around, you're letting anyone who wants to use it get just the right piece of information they want and nothing more. So this is kind of the end of the code I've got for it. A quick word on threading. I haven't talked about it at all much, and it's kind of deliberate because RX generally doesn't do any deliberate threading except for things like timers, where you need some kind of background thread to run a timer on. Apart from that, RX will never go, oh, you want a background thread for this, you want this to run in parallel. RX will call you back on the thread you called it on, which is a good thing. And if you're doing lots of moving around, hopping between threads, it's probably not a good thing, and it's going to confuse the hell out of you because it confused the hell out of us. If you do need to shift threads, the most common case will be because you need to get back on the UI thread, or you need to do some work off the UI thread. The cleanest way to do that will be to move threads when you're actually creating an observable. You're right at that boundary between, say, an event and an observable, or you're getting a call off a web service or a TCP connection or something, or at the very other end when you're subscribing, you're just about to deal with one value. Everything in the middle where you might be aggregating, skipping, selecting, whatever, if you're multi-threading that, you're in for a world of hurt. So, and sort of, if you think about it, the only two places you could actually reasonably think about what thread matters is because you're coming off a thread that you don't want to be on anymore, or you're coming in on a thread and you need to tell someone, like on a dispatcher for a UI, you need to get off onto a different thread to tell someone something. Everything else you shouldn't really care about threads. So in terms of getting started, as I sort of talked about, there's definitely a learning curve with RX, and it's not a small one. It's partly down to this change in mindset and thinking about event flows, that kind of thing. There's plenty of it's just down to the framework and the extension methods, especially if it's not something you're familiar with. But it's also thinking about your application in a sort of a reactive way rather than an imperative way, where you're sort of dealing with one thing at a time. if you like Link, if you've had lots of experience with Link, you'll find it a lot easier. And if you've done functional programming, which I haven't, I suspect you'll find it a lot easier to think in this way because it's about sort of transformation and statelessness and so on. If you're looking to learn more, there's not a lot of resources out there, but the ones that are out there are generally pretty good. If you want to get started and you've never used it before, RxMain will get you Rx off NuGet. Intro to Rx.com was written by a guy I worked with, Lee Campbell, and that's a really good place to learn Rx from scratch. The name's a bit deceptive because by the end of it, it's gone well beyond an introduction, but it's quite a well-structured book. It's free to read on his website, or you can buy it off Amazon for 50 cents or something like that. He found it easier to publish with a price than not publish for free with Amazon, so you have to pay 50 cents to get it on your Kindle. It's well worth the 50 cents. But actually, I find his book and his content so useful, I've set up a little shortcut on my computer that will use Google to search his website for some particular keyword, because I know, wait a minute, Lee talked about that, he said something, and I just search his site for this, and then I go and read it. I'm like, oh, okay, right. So it's a really good resource. There's heaps and heaps and heaps of stuff on Channel 9, and it's lots of videos being published. Rx is not a new thing at all. They started talking about it in 2009, so there's a lot of back history there. And just one word of advice would be to watch the most recent ones first, because they changed the interface quite a bit over the years, so it's gotten a lot more stable since RX2. The RX team blogs, and they're quite useful. There's Bart DeSmet and so on, but I've actually had trouble finding a blog of his on RX. He's got a blog not on RX, but I don't know if he ever, although he used to blog on RX. But yeah, the RX team is a good place to go. And the MSDN forums for RX, if you go and post there, you'll get Lee, who wrote the intro to RX, answering. You'll get Bart DeSmet, you'll get guys who've written a sort of semi-official extension libraries. You get sort of the people who really know what they're talking about will come on. They're really helpful guys. It's still quite a small community, so there's not too much flaming, that kind of thing. It's quite helpful. I think that's pretty much it. I know a lot of this content's quite dense and can be quite hard to absorb when you've never used it at all. And even, I still find it quite a challenge to think about a new concept and map it into RX. So if you do have any questions, feel free to get in touch. And if you want someone more intelligent than me, then go to the RX forums or just go straight to Lee, because everything I learned from Lee, and he'd probably be disappointed by how much I didn't learn. So that's pretty much what I've got. If there are any questions, feel free to fire away.
Did you pull it into the GUI as well, like the usual .NET sort of event model?
Yeah, so I'm trying to remember exactly how it was done, but there were... we were using, it was Silverlight, and so the command model, we were binding to commands off the buttons and so on. And I think someone had created an observable command or something like that. It's been a while since I looked at the UI side of it, but it was definitely, like the view model would be reacting to an observable of, save button clicks or whatever like that. And what we found is sort of the sooner you got into the observable and started dealing with those flows of events, and you sort of say, okay, so from a save button click, select the server response to my posting this request, that kind of thing, and then subscribe to that and put that response on the screen, and you'd have your request response in sort of 3 lines of code, all sort of captured in one spot. And so the sooner you're inside the observable, sort of the cleaner it went. So a lot of the demos, the early demos, were about user UI events and drag drop and so on, which I think they neatly show composability, but I don't think they show business purpose, because I think the real power of RX is in munging data. And if you've got, if you want to build like business analytics on your data flow that are real time, or you want to suck down Twitter and look for patterns in Twitter, you could be looking for people talking about stocks, and if people suddenly start saying buy BP, you want to go and buy BP before everybody else in the world does. And that I think that RX is really well suited to that. And I think it gives you, it's much harder to do that kind of thing without RX than it is to do UI without RX. Cool. All right. Oh, well, thanks for listening.
Thanks,
I hope it was useful.